Welcome to our exciting journey into the dynamic world of volcanoes and earthquakes. In today's episode, we'll explore how tectonic plates move, how these movements can lead to earthquakes and volcanic eruptions, and the extraordinary forces that shape our Earth. We'll also delve into some fascinating facts about these natural phenomena, including the incredible events that have occurred throughout history. So, buckle up and let's unlock the mysteries of our planet's geology together. Let's start by discussing tectonic plates. Imagine the Earth's surface as a giant puzzle made up of large pieces, known as tectonic plates. These plates float on a layer of molten rock called the asthenosphere, which is part of the upper mantle. Over millions of years, these plates shift and move, causing earthquakes and volcanic activity. The theory of plate tectonics proposes that the lithosphere, which comprises the crust and upper mantle, is divided into these large plates. But what drives their movement? It's mainly due to the heat from the inner layers of the Earth, which creates convection currents in the mantle. These currents push the plates around slowly, at about 1 to 10 centimeters a year. That's roughly the same speed at which your fingernails grow. Now, let's transition to earthquakes, which are among the most dramatic consequences of tectonic activities. An earthquake occurs when the stress accumulated along geological faults is suddenly released, causing the ground to shake. This shaking is the result of seismic waves which travel through the Earth. The focus is where the quake originates deep within the Earth, while the epicenter is the point directly above the focus on the Earth's surface. When we hear about the strength of an earthquake, it is usually referenced by its magnitude, which can be measured using the Richter scale or the moment magnitude scale. The higher the number, the more energy was released during the quake. Let's shift our attention to the types of plate boundaries. There are three main types: divergent, convergent, and transform boundaries. At divergent boundaries, tectonic plates move apart from each other, leading to the formation of new crust, such as mid-ocean ridges. In contrast, at convergent boundaries, plates collide, often forming mountains and volcanic activity. Lastly, we have transform boundaries where plates slide past each other, causing friction and earthquakes. For instance, the Mid-Atlantic Ridge is an example of a divergent boundary where new ocean floor is created as the plates pull apart. Now, let's talk about volcanoes. A volcano is an opening in the Earth's crust that allows molten rock, gases, and ash to escape. This often happens at convergent boundaries, where one plate is forced beneath another, and at divergent boundaries as plates separate. You may have heard the terms magma and lava. Magma refers to molten rock found beneath the Earth's surface, while lava is what we call it once it erupts onto the surface. Volcanoes can be awe-inspiring but also dangerous. They can erupt explosively, producing pyroclastic flows, fast-moving currents of hot gas and volcanic materials that can reach staggering speeds and temperatures. These flows are one of the most deadly volcanic hazards known. In fact, in 1902, the eruption of Mount Pelee in Martinique resulted in the devastation of the town of Saint-Pierre, tragically killing around 30,000 people in moments. Transitioning to seismic waves, which are crucial to understanding earthquakes, these waves are energy that travel through the Earth following an earthquake or volcanic eruption. There are two primary types: body waves and surface waves. Body waves include P waves, which are compressional waves and travel fastest, and S waves, which are shear waves that arrive afterward. Surface waves, like Love and Rayleigh waves, typically cause the most damage during an earthquake due to their larger amplitude and slower speed compared to body waves. Now, have you ever wondered what happens when an earthquake occurs under the ocean? Most often, this can lead to tsunamis, a series of enormous waves that travel across the ocean at incredible speeds. A prime example is the 2004 Indian Ocean tsunami, which tragically claimed around 227,000 lives. Tsunamis are primarily caused by underwater earthquakes, which disturb the ocean floor, displacing large volumes of water. One of the most notable regions for earthquakes and volcanic activity is the Ring of Fire, a horseshoe-shaped area in the Pacific Ocean. This zone is about 40,000 kilometers long and contains approximately 75% of the world's active volcanoes as well as 90% of the Earth's earthquakes. It is largely shaped by the tectonic activity surrounding the Pacific Plate, where various tectonic boundaries meet. This leads to numerous geological events and explains why the Ring of Fire is so active. The insights we gain from monitoring these activities are essential for understanding natural disasters. Scientists use advanced instruments like seismometers for earthquakes, gas sensors to detect volcanic gases, GPS for ground deformations, alongside thermal cameras and satellite imagery. An uptick in earthquakes, swelling of the ground, and gas emissions can often signal an impending volcanic eruption, providing critical warning signs to nearby populations. Speaking of safety, during an earthquake, it's essential to know the recommended safety procedures. Remember the phrase drop, cover, and hold on? When the shaking begins, drop to the ground, take cover under sturdy furniture, and hold on until the shaking stops. Avoid standing in doorways and stay away from windows and heavy objects that might fall. Knowing these safety measures can be life-saving. Now that we've journeyed through the study of earthquakes and volcanoes, let's recap what we learned. We began with tectonic plates, massive pieces of the Earth's surface that shift, causing geological activity. We discussed how earthquakes occur due to the sudden release of energy along faults, and how they are measured in magnitude. We also covered the different types of plate boundaries and their geological impacts, including the creation of new landforms and volcanic activity. We explored what constitutes lava and magma, and the sheer power of pyroclastic flows. Lastly, we highlighted the significance of safety precautions during earthquakes and the incredible technologies used to monitor these natural phenomena. Thank you for joining us today as we explored the fascinating worlds of volcanoes and earthquakes. We hope you learned something new and are inspired to continue exploring Earth science. For more resources and information on these topics, be sure to check out trusted websites like the U.S. Geological Survey and National Geographic. Keep questioning and keep exploring, and we look forward to having you with us for our next adventure in science.